Part 3 is finding the molecular formula. So there's a lot of different steps up here, and it breaks it down for you so you can follow the steps. When I do the actual problems, I'm going to make it a little bit easier than these steps, but some people need the actual words to show them. So step 1, calculate the molar mass for the empirical formula. So step 1, molar mass of the empirical formula. Step 2, find the molecular molar mass given in the problem. You don't have to calculate it, it is given. So step 1, you calculate. Step 2, the given. Then you're going to take those two values and plug them into this equation. So out of everything that's on this board or in your notes, because it might be a little bit fuzzy looking, so look at your notes, this is key. You have to know this. N, molecular molar mass divided by the empirical molar mass. So the given number divided by what you calculate. Given goes on top, what you calculate goes on the bottom to find just a number. N just means number. And whatever you get from that, you're then going to multiply each subscript in the empirical formula by N. So you just do N times the subscripts to get your answer. So this, whatever you get here, is your answer. So let's dive in. What is the molecular formula of CH2O if the molecular molar mass is 120 grams? So step 1 is to find the empirical molar mass. We find the empirical molar mass by finding first the empirical formula given to you in the problem. So this is our empirical formula. So we need to find the mass of that. We need to find the mass of CH2O. So carbon is 12. Hydrogen is 1 times 2. Oxygen is 16. And you add that up. So we get 12 plus 2 plus 16, which equals 30. That's step 1. Step 2 is to find the molecular molar mass given to you in the problem. So step 2 just means to look at the problem given and find the number value in there. So 120 grams is the molecular molar mass. That is step 2. So we know the empirical is 30, and we know the molecular molar mass is 120. Step 3 is to now just find N, which is just an arbitrary number that you find. So you're going to do molecular molar mass divided by empirical molar mass. Or, if you want to learn it this way, the given divided by the calculated. So in this case, the molecular molar mass, the given, is 120. The empirical molar mass is what you calculated, which is 30. So 120 divided by 30 is 4. Now, one of the most common mistakes is to take that 4 and put that as an answer. But I am asking for a molecular formula, a chemical formula. So step 4 is to take that 4 and multiply the subscripts of your empirical. So our empirical is CH2O. So you get C4H8O4. Final answer. Now some students, for whatever reason, then ask me, do I need to reduce that? And I sort of look at them with a confused look, because why would you want to reduce that when you just did all this work to get those numbers? Because if you reduce it, you're simply going to go right back to what you had. So this is the final answer. Now it's your turn. So pause the video. Check your answers. Make sure you did it correctly. If you have any questions about this, please put it to the side on your notes and bring them back to class the next day. Or ask one of your classmates. This is the last problem for today. This is where I'm going to combine the last two things that we talked about into one problem. So you have a bunch of numbers in this one problem, and I'm asking for two things. So I'm giving you a bunch of percents, and then I give you a grams amount. And I'm asking for empirical and molecular. So, which one do we need to find first, empirical or molecular? Well, you need the empirical formula to solve for the molecular. So the first thing we need to do is find the empirical formula. So we just roll through the steps. Percent to mass, which means you just change these to G's. And now mass to moles. So 40.68 grams of carbon, convert. 5.08 grams of hydrogen, convert. 5.424 grams of oxygen, convert. So carbon is 12 grams per 1 mole. Hydrogen is easy. Oxygen carbon 3.39, hydrogen 5.08, oxygen 54.24 divided by 16, 3.39. So then, our next step, we went from mass to moles. Now we're going to divide by small. In this case, we have two values that are small. So we're going to divide both sides by, or all the values by 3.39. So we get 1. And then here we get 1.5. So then comes step 4 in the empirical formula part. Multiply to a whole. So again, if you get that 0.5 in there, we need to multiply all of the values by 2. So 1 times 2 is 2. 1.5 times 2 is 3. And 2. So this means our empirical formula is C2H3O2. So we found the empirical. Okay, I'm going to switch colors so you can see how we go to the next piece. We found the empirical is C2H3O2. Now we need to find the molecular. Well, now that we have the empirical, molecular should be easy. Step 1, find the molar mass of C2H3O2. So C is 12 times 2 is 24. Hydrogen is 1 times 3, which is 3. Oxygen is 16 times 2, which is 32. 24 plus 3 plus 32 gives you 59. Okay. Step 2 is to find the molecular molar mass, which is this gram value given right there. And then step 3 is to do the molecular molar mass divided by the empirical. So the molecular molar mass is the given, so 118.1 divided by 59. Which gives you 2. So then step 4 is to take that 2 and multiply the subscripts of C2H3O2. So your final answer for the second part is C4H6O4. That makes this the end of the video.